Hello, in this video, we are going to review adding and subtracting rational numbers. When we talk about rational numbers, this video is meant for those that are at a normal 7th grade level. So we're only talking about positive and negative fractions and mixed numbers. There will not be any decimals, repeating decimals, or any other things that fall under rational numbers in this case. So we're going to be adding and subtracting rational numbers. In this video, we'll be focusing specifically on when you have to regroup when you do your subtracting. Now, in my classes, I try to always stress good math habits and algebra procedures. With that said, I am not going to take these fractions and rewrite them vertically, put equal signs on the right, and solve the way that it is done in many classrooms. A while back, I continually stressed to my students that they should be following algebra procedures, and yet every time I did fractions, I started getting questions of why did I not follow algebra procedures when doing them? And I didn't really have a good answer. So I tried it, and the students seemed to like it a lot, especially since in that class we stressed algebra style work all the time. This is not algebra work, but we're going to be doing it working in a downward movement, like so that you get used to how algebra work does get written. So the first thing I want you to do when doing these problems, we have 8 and 5/9 minus 5 and 2/3. There's no negatives. We can just start working on finding a common denominator. So underneath the 8, you're going to put an 8 fraction, put a fraction bar. Under the minus, put a minus. We're going to work down. Under the 5, put a 5, and under 2/3, put a blank fraction bar. And then you need to find a common denominator. Now, in this case, our denominator is 9 and 3. A really good common denominator would be 9, because 3 times 3 is 9. So we'll do 9 times 1 and 5 times 1. 9 times 1 is still 9, and 5 times 1 is still 5. And then we have 3 times 3 gives us the 9, and 2 times 3 gives us 6. Now, I do need to notice that when subtracting, the bigger number always goes first, or the bigger absolute value always goes first, and 8 is bigger than 5. Since 8 is bigger than 5, we must subtract going to the right. But when I try to do that with my numerators, because with fractions, you subtract your numerators, denominator stays the same, I can't do 5 minus 6. The 5 is too small. And I can't do negatives because I'm doing the bigger number, subtracting the smaller number. The 8 is the whole number here. It's bigger than 5. I must subtract in this order. I must be able to do my numerators, subtract in the other numerator. So what I'm going to do is borrow. I'm going to rewrite the problem because organization is important. And I'm going to borrow from the 8. It'll become a 7. Now, when I borrow from the 8, it becomes a 7. I borrowed 1 whole. I'm going to add that 1 whole as a fraction to 5/9. And because I want my denominators to be the same, it's going to be 9/9. Now, when I add this little 1 whole to my 5/9, I wind up getting 14/9. Then my whole number is now a 7, and I can just copy the second fraction, or the second mixed number. Once I've done that, I borrowed from the 8, it became a 7. I added 1 to 5/9 in the form of 9/9. I now have 14/9, and I can subtract my numerators. 14 minus 6 is 8. Denominator 9 stays the same, and 7 minus 5 is 2. So our answer is 2 and 8/9. Let's try this again. I'm going to do my work like algebra, which just means I'm going to rewrite each line as I do work. So I have a -6, I have a fraction, I have a plus sign, I have a 9, and I have a fraction. Now, the reason this is going to be regrouping, even though there's a plus sign, is that the signs are different. And when the signs are different, you're going to subtract. So let's find a good common denominator for 4 and 8. Good common denominator would be 8 because 4 times 2 is 8, 3 times 2 is then 6, 8 times 1 is 8, and 3 times 1 is then 3. The problem is we are going to subtract the bigger absolute value minus the smaller absolute value, which just means when we don't look at the signs, subtract the bigger one minus the smaller one. But the 9 is bigger. So we're not used to going to the left when subtracting. We're so not used to it that I'm literally going to draw an arrow there to remind myself during the entire problem that we are subtracting going to the left. So when I try to do 3 minus 6, I can't. The 3 is too small. We're going to have to borrow. We'll borrow from the 9. It'll become an 8. We borrowed 1 whole because 9 minus 1 is 8. That 8 should have a denominator of 8. So we're going to add in 8/8. That gives us 3 plus 8 is 11. Denominator stays the same. We'll bring down our new whole number of 8. And the other fraction we can just copy or make number. Now again, remember, we are subtracting to the left. And now that my numerators are in the right order, the bigger one is subtracting the smaller one, I can do 11 minus 6 is 5. Denominator 8 stays the same. And then 8 minus 6 is 2. The 8 is a bigger absolute value. The 8 is positive, so my answer is positive. So again, all you're going to do is set, and these problems are normally mixed in with all your other problems. You don't know you're going to have to borrow until you get to a point where you go, oh, the 3 is too small to subtract 6. You don't know that ahead of time. These problems are mixed in with all your other addition and subtraction problems. So once you realize it's too small, you draw the arrow and you borrow. Let's do one more. So I'm going to write my problem with the fractions blank. I'm going to find a good common denominator, 15 and 5. A good common denominator would be 15, because 5 times 1 is 15. That means I do 2 times 1 is 2. And 5 times 3 is 15, which means I'll do 3 times 3 is 9. So now I have a good common denominator, 15. I have an 8 minus 2. That's normal subtraction. We can do that. And we're going to subtract in our normal order, 8 minus 2. Problem is, when I go to subtract, I notice, oh, I can't do 2 minus 9. And it's at that point, when you realize you can't do the subtraction, that you know you have to borrow. We will borrow from the 8, it'll become a 7. We'll borrow one whole in the form of 15 over 15, and then we'll get our new fraction. 2 plus 15 is 17 is our numerator. Denominator stays the same. And we now have a 7 in front. Then we'll copy the other mixed number. Now when we go to subtract 7 minus 2 with our numerators, 17 minus 9, we get 8. Our denominator 15 stays the same. And then we can do our whole numbers. 7 minus 2 is 5. So again, when you are going to have to borrow, you borrow one whole, you add it in the form of a fraction, and you should rewrite the entire problem because organization is important. And if you rewrite it on the next line with your new numbers, you're less likely to make some kind of silly mistake. Thank you.